Hi guys, welcome back to our lesson on probability. Remember, we're asking the question, can mathematics help us to predict the future? And this area of mathematics is called probability. Now, it's very closely linked to statistics, but we're just focusing on probability. And in the first little part of this lesson, we've established certain things about theoretical probability. Let's have a look at our concept map. So within our ideas of theoretical probability, we've got a definition for how to calculate probability. We can say the probability of an event that we would like to happen. So I'm going to say the probability of an event is equal to the number of times that event can happen divided by the total number of things that can happen, events in total. And I'm using S there to represent the sample of all possible events that can take place. So the probability is the event that we would like to happen divided by the total, and we can represent this as a percentage or as a fraction or as a decimal fraction, or we can even represent it as a ratio. So be very clear about this idea of theoretical probability. And so you might read or you might see in the newspaper or listen on a TV show that the probability or the chance of rain on a particular day might be 50%. What does that actually mean? It means of all the days and all the possible outcomes with these conditions, 5 out of 10 of them would have experienced rain in the past. That gives us the idea of probability, that it's predicting based on previous data that we can think that tomorrow there's a possibility or a probability that we could get rain happening. So you'll see that in the weather forecasts. But you can use this in everyday language as well. The possibility or the probability of an event taking place sometime in the future. And so we did a little experiment before the break, and you can do similar experiments. What we need to recognize is sometimes the experiment doesn't match with the theory. And so we need some new terminology when we're looking at actual experiments. So we're going to be looking at some probability experiments, and we want to make some definitions of things that we're going to be looking at in this situation. So when we're doing probability experiments, we call each experiment is known as a trial. So that trial could be, for example, tossing a coin or throwing a dice. Every time you do that, that's a trial. It's part of the bigger experiment. And we could do only 3 throws of a dice, or we could do 30 throws of a dice, or 300 throws of a dice. And each time we'll collect some data that will help us recognize what are the most likely outcomes. Remember that the result of a trial of a particular thing is called an outcome. It can also be called an event. It could be a favorable event, or it could be an unfavorable event. We're not worried, but it is an outcome. Okay, so the next idea we're going on to is this idea of relative frequency. Relative frequency is the number of times that an outcome occurs during experimental trials. And what we recognize that to get the relative frequency is not just to calculate the total number of times it happens, but to count it divided by the total number of trials conducted. So if I do 10 spins of a coin, of a spinner, and I find that the number of times that the spinner lands on blue, for example, is only 2, then the relative frequency of something blue coming up on the spinner is 2 out of 10. Now, I've spoken about the spinner without actually showing you a spinner, so let's hopefully get into that spinner right now. So there's our spinner. As you can see, this needle here is a free floating needle, and it can spin. At the moment, it's on the blue square. We recognize it's touching blue, but we can let it spin freely, and it will stop wherever, and it can stop at the blue square, it could stop at the red square, it could stop at the cyan square, or it can stop at the yellow square, or quarter segment. But, so much for talking about little graphics. How about let's go and do it? But before we do that, I'd like you to think about some questions, because before every experiment, we must make some predictions. We've got to think about what the possible outcomes could be. Apply some probability thinking. So here are some questions I'd like you to think about. Can you calculate the theoretical probability that the pointer will land on the blue section after just one spin? What will the theoretical probability be after 4 spins? Got any ideas about what we could be doing? Do you think the theoretical probability will change, or will it remain the same? Well, think about it. Remember what our definition for probability was. We said it's the probability of a particular outcome, in this case the blue segment that we wanted to land on, is the total number of times that it lands on the blue divided by the total number in the sample. Remember, the sample space is the total number of possible outcomes. Okay, so I hope you've got an idea. For 1 spin, how many outcomes could there be? For 4 spins, how many outcomes do you think there could be? Think about it and see if you can calculate the probability. Now, if we're actually going to do the experiment, can you make a prediction about what you think on the first spin? Is the needle going to land on the blue, or is it going to land on another color? What are the chances? And if we did for 4 spins, what are the chances? Would you like to make a prediction? Take a piece of paper, write it down. How many of you think that there's a chance that it will land on the blue, the needle will point to a blue section? What about a red section, or a yellow section, or the cyan section? Well, let's have a look and see. I think it's time to actually step into the laboratory and let's go and look at a real spinner. Now, this spinner is something that we can call up, and here it is, and I want to just reset because I was playing a little bit earlier, and we're going to recognize that we've got 4 possible outcomes. So it could be on red, blue, cyan, or yellow, and we recognize that we're going to calculate the experimental probability has already been calculated for us. They're equal in size and shape, and so this experimental idea tells us that there's a 1 in 4 chance of it landing on a particular square. And so in the table over here, we have been given that the theoretical probability is 25%. But if we actually let it spin, where do you think it's going to land? Let's see. It landed on the blue square. Isn't that amazing? Out of 1 spin, we wanted it to get to blue, and it got there. So the relative frequency, do you see? The relative frequency was, we wanted the outcome of blue, so that was 1. And how many spins was there? There was 1. And what's the relative frequency? I hope you can see it's 100%. It's not like the probability because we've only had 1 spin. Let's add a few more spins and let's see what happens. So I'm going to spin it again. It didn't land on blue this time. It landed on yellow. So the percentage of my theoretical or relative frequency has gone down. It went from 100% to 50%. And so it's getting closer to the theoretical probability. Let's see what will happen if we spin it again. This is the 3rd spin. No, another color this time, not blue. I really wanted it to happen to blue. But you can see what's happened to the theoretical, or not to the theoretical probability stayed the same. It was 1 in 4, 25%, but the relative frequency is no longer at 100, it's no longer at 50, it's come down to 33%. 4 spins. Let's see what we'll get. Look at that. It tells me that it's got a blue spinner. It's got a blue quadrant. So what are we back to? What's our relative frequency? We've got, out of 4 possible outcomes in our 4 trials, we've got 4 possible outcomes, and 2 of them are telling us it's blue. So blue's relative frequency is 50%. It's gone back up. It hasn't gone to where we wanted it to be, like the probability. But you know what? Let's speed up the number of trials. And so I'm going to change this and see what will happen if I make this spinner spin, say for example, 10 times. And if I let it spin and I let it skip to the end, look what's happened. The leaderboard has changed. We found that after a total of, if we add all of these up, which would be 7 and 4 is 11, 12, and 2 is 14. 14 spins so far. We've got yellow sitting on a 50% experimental relative frequency. Blue is only sitting on 28.6%. And cyan sitting at 14, and red is way back in the doldrums. But you know what, guys? Let's change this number. Let's change it. We're at 14. I want to get it to 100. So if I take that, I'm going to make it 86 spins. And let's see, in 100 spins, what will happen. So I'm going to let it spin, and I'm going to say, let it skip to the end. And now it's done 100 spins. And what do you notice? Look carefully at these results, because the more times we spin the spinner, the closer the relative frequency is getting to the theoretical probability. Look, the blue is at 25 times that it's got to the blue count. So 25 out of 100 is 50%. It's exactly what our probability predicted. The cyan was also 25 times out of the number of spins. So it's also 25 out of 100. So it's also 25%. The difference is that it's not quite perfect for the yellow and the red. But you know what? I'm going to change it. I'm now going to make an extra couple of spins. And I don't know if it will do it, but I want to see if we can push it to make 900 spins. That will give us a total number of spins of 1,000. And we'll then be able to see if there's any correlation between the relative frequency, which is the actual events happening, and the theory, and see how closely those are matched together. So let's spin for 900, and let's hope that we're going to get there, and we're going to skip to the end to get our results. And what do you notice? We are getting closer and closer to the probability value. Our relative frequencies are very close to 25%. Some of them are 24.7%, some of them 24.2%, but they're getting closer and closer. So if I did another 1,000 spins, instead of just 900, let's do 1,000. Let's change it, make it, I've made it 1,000, and let's spin. So now 2,000, let's spin to the end. We're not going to wait it. And look, the values are getting even closer. So in doing this experiment and seeing that there's a difference between theoretical probability and relative frequency, I hope you can see that we can make some predictions, that our idea of the spinner is not so far-fetched. What conclusion can you make about the relationship between relative frequency and probability? Well, you see, it all matters about the number of times, the number of trials you go. So when we get lots of data, big data, then probability is a very good model for predicting what might happen. And so if we have to answer our question, can mathematics help us predict the future? All depends on how much data you've got. Think about it. We'll be back after this short break.